In the summer of 2022, the James Webb Space Telescope, JWST, began its mission, stationed approximately 1.4 million kilometers from Earth. It was hailed as the successor to the Hubble Space Telescope, with an ambitious goal: to search for the oldest light signals in the universe. Webb was envisioned as the tool that would peer into the dawn of space and time, unraveling mysteries of the cosmos from its earliest moments. However, when the first images from Webb were released, they revealed something unexpected. Rather than simply seeing the beginnings of the cosmos, Webb's images began to challenge long-standing cosmological views, suggesting that our understanding of the universe may have been flawed all along. Amid all the excitement surrounding Webb's discoveries, a major revelation from earlier in 2022 was almost forgotten. In March of that year, when no one anticipated a groundbreaking discovery from the aging Hubble Space Telescope, scientists were stunned by the identification of the oldest single star ever observed. This ancient star, initially catalogued with the technical name WHL0137LS, soon became known by a much more poetic moniker, Arendelle, the Star of the Dawn. The name Arendelle, derived from Old English, means morning star or rising light, a fitting title for such an ancient celestial object. Fans of J.R.R. Tolkien's work may also recognize the name, as Arendelle in his mythology represents the morning and evening star, an immortal light that guides the elves. This mystical name seems appropriate, given that Arendelle's light has journeyed through space for nearly 13 billion years before reaching Earth. The discovery of Arendelle was nothing short of astonishing. The star's light was first detected by Hubble through a phenomenon known as gravitational lensing. The gravitational forces from a galaxy cluster, WHL01378, acted like a magnifying glass, amplifying Arendelle's light to make it visible, despite its incredible distance from us. This phenomenon is comparable to moving a curved magnifying glass over a map. Certain sections become magnified while others distort. The galaxy where Arendelle was located, at the edge of the sunrise arc, seemed to hold secrets from the dawn of time. Based on early estimates, Arendelle was thought to have formed approximately 12.9 billion years ago, just 900 million years after the Big Bang, making it one of the first stars in the universe. At the time of Arendelle's discovery, scientists still believed it was one of the earliest stars formed in the universe, loosely scattered across space after the Dark Ages, a period of cosmic history where the first light had not yet broken through. Yet, the gravitational lensing effect, combined with Hubble's sharp eye, allowed humanity to glimpse this ancient light. It was as if Arendelle had been illuminated through a cosmic magnifying glass, a chance occurrence that made it visible from such an immense distance. Everything seemed settled about Arendelle's place in cosmic history, until the James Webb Space Telescope came along. As soon as JWST started producing its own deep-field images, the assumptions about the early universe began to unravel. The discoveries Webb made in those first few images overturned long-held views. Among them was a closer examination of Arendelle, which confirmed Hubble's findings, but also suggested a more complex and nuanced understanding of the early universe. Webb's images provided a sharper view of Arendelle and the surrounding sunrise arc. In this image, the brightest and closest objects were blue-white stars, which are much younger than Arendelle. By contrast, Arendelle's light appeared faint and red, hinting at its ancient origins. Arendelle's mass is estimated to have been between 50 and 100 times that of our Sun, categorizing it as a blue giant star. Blue giants are among the brightest and hottest stars in the universe. However, despite their immense size and luminosity, they have short lifespans. Astronomers believe that Arendelle, like other blue giants, likely burned through its fuel quickly and no longer exists today. The star's light has taken 12.9 billion years to reach us, and given the expansion of the universe, the star would now be located about 28 billion light-years away, beyond the reach of even the most advanced telescopes like Webb. The light that Webb captured from Arendelle traveled an unimaginable distance and time to reach us, providing scientists with invaluable clues about the star's nature. Webb's highly sensitive instruments, using 8 different filters, allowed researchers to study the light's characteristics in detail. From this, they concluded that Arendelle had a surface temperature ranging between 12,000 and 15,000 degrees Celsius, making it much hotter than our Sun, which is classified as a G-type star. Its brightness was estimated to be up to 1 million times that of the Sun, which is extraordinary. However, there is still some debate about whether Arendelle was indeed a single star. It's possible that what we observed could be a binary star system or even a multi-star system. Large stars like Arendelle often attract other stars into their gravitational orbit, forming these kinds of stellar systems. Yet, if Arendelle was indeed a single star with such immense luminosity, it would challenge existing models of stellar brightness, specifically the Humphreys-Davidson limit, which describes the empirical upper limit for the luminosity of stars. Arendelle's existence could force scientists to revise this limit, as its brightness may have exceeded what was previously thought possible for any star. Before Webb's arrival, Arendelle was thought to be a star from the first generation of stars, known as population 3 stars. These early stars were formed almost entirely of hydrogen and helium, the 2 lightest elements created during the Big Bang through a process known as primordial nucleosynthesis. Population 3 stars had almost no metals, a term in astronomy used to describe any element heavier than helium, such as carbon or oxygen. While these early stars are believed to have burned out quickly, their remnants are nearly impossible to observe today. Scientists hope that Webb will be able to uncover more of these ancient stars, offering further insights into the early universe. However, even as Webb continues to push the boundaries of our understanding, its discoveries are reshaping our views of cosmic history. Webb has already identified galaxies that are even older than Arendelle, some dating back 13.6 billion years. These galaxies formed just 200 million years after the Big Bang, a time when scientists previously believed only individual stars could exist. The presence of fully formed galaxies at such an early point in the universe's history challenges the very foundations of the Big Bang model, forcing astronomers to reconsider how the universe evolved in its earliest stages. As new data emerges, it appears that Arendelle's position as the oldest known star may soon be surpassed by other, even older discoveries. While Webb cannot detect individual stars in these distant galaxies, the telescope's power and the gravitational lensing effect may one day reveal even older stars. Each new discovery adds another piece to the cosmic puzzle, helping us refine our understanding of the universe's origins and evolution. The discovery of Arendelle, while groundbreaking, is just the tip of the iceberg when it comes to unraveling the mysteries of the early universe. Its light, having traveled 12.9 billion years to reach us, serves as a time capsule from a period when the universe was still in its infancy. This window into the past allows scientists to probe the formation of the first stars and galaxies, offering clues about the conditions that prevailed shortly after the Big Bang. However, with the James Webb Space Telescope revealing fully formed galaxies much earlier than expected, it's clear that our models of cosmic evolution may need to be significantly revised. The discovery of ancient galaxies and the confirmation of Arendelle's extreme luminosity point to a more complex and nuanced early universe than previously thought. Webb's capabilities continue to push the boundaries of astronomical research, providing an unprecedented look into the deep past. The telescope's ability to observe in infrared allows it to peer through the dust and gas that obscure older, cooler objects in space, shedding light on the processes that led to galaxy formation. The discovery of galaxies over 13 billion years old, far exceeding the anticipated timeline of star formation, raises fundamental questions about how such massive structures could have emerged so soon after the supposed beginning of the universe. This could imply that the universe is older than we currently believe, or that the processes of star and galaxy formation occurred at a much faster rate than previously modeled. The implications of Arendelle and these ancient galaxies go beyond astronomy. They touch on our understanding of the very fabric of the cosmos. If the Big Bang Theory, with its well-established timeline, is found to be inaccurate, this would necessitate a rethinking of cosmic chronology and physics. For decades, the Big Bang model has served as the cornerstone of cosmology, but the discoveries made by Webb suggest that the universe might have evolved differently than what scientists have predicted. The presence of fully formed, highly luminous galaxies so soon after the universe's inception defies the expected slow progression from individual stars to galaxies, indicating a much more dynamic and rapid development of the cosmos. Thank you for joining us today on Space Lab. If you enjoyed this deep dive into the universe's mysteries, make sure to hit that like button, subscribe, and turn on notifications so you don't miss out on our latest explorations. Stay curious, keep looking up, and we'll see you next time on Space Lab, where we bring the wonders of the cosmos to you.